So today we are going to talk about experiment number 2. I have already introduced my loop or looping concepts with you, right? So why basically we use loops is because we want set of statement or a particular statement to execute again and again. So that is the purpose of using loops. Now, to understand more about loops and how to use the loops in C programming language, we will now do few more programs where we have to use loops. So that program number 1A, write a C program to generate first n terms of Fibonacci sequence. Now I hope you all know what is a Fibonacci sequence. In Fibonacci sequence, the first two digits are 0 and 1, and the next term is calculated as the addition of first two terms or previous two terms. So what should be the next third term? Addition of 0 and 1, that is 1. What should be the next term? Addition of previous two terms, that is 1 and 1. So it is going to become 2. What should be the next term? Previous two terms, that is 1 plus 2, that is 3. Then next term, addition of previous two, that is 5. The next 8, next 13, next 21, next 34, and so on. This is the Fibonacci series. What the logic is? The current term is calculated as addition of previous two terms. Is this clear? Alright. Now, what is the second statement in this program? Is write a C program to generate prime numbers between 1 to n. So, what is mean by prime number? So, 0 and 1 are not prime numbers. 0 and 1 are not prime numbers. Now, apart from that, we have other numbers as prime numbers. So, what is definition of prime number? The number which are divisible by 1 and itself. What I said, the number which is divisible by 1 and itself is called as prime number, right? So, if we started finding the prime numbers, so 2 is divisible by 1 and 2 itself, so can be considered as prime number. Then 3 can be considered as prime number. 4 can be considered as prime number. 1, 2 and 4. It is not just getting divisible by 1 and 4. 2 can also divide 4, right? So 4 is not the prime number. Then 5, right? Then 7. Then is 9 prime number? Everyone? No, it is not a prime number. Then 11, then 13, then 17, then 19, then 23, and so on. That is the prime number. Is this clear? Okay. And then finally, in last program, that is C, what we are going to do, we are going to check whether a given number is Armstrong or not. Given number is Armstrong or not. So what is the definition of Armstrong? So what is Armstrong number? A number which is formed, or if a number is formed with the cube of the digit of any number. For example, I have a number 1, 2, 3, and when I am forming a new number as 1 raised to 3 plus 2 raised to 3 plus 3 raised to 3. So addition of cube of each digit gives us the same number. Then we call it as a Armstrong number. Is this clear? So whether 123 is Armstrong number? See, 1's cube will be 1 plus 2 cube is 8 plus 3 cube is 27. So if we do the addition, that addition comes to be 36, right? So is it 123? No. So it is not a Armstrong number. Now one more example, 153. So 1 cube plus 5 cube plus 3 cube. So let's find out the answer of each of these. 1 plus 125 plus 27. Do the addition. It comes to be 153. So the original number and sum of the cube of the digits of that 153 comes to be 153. So it is a Armstrong number. Is this clear? Right? Okay, fine. So that is what we are going to do in experiment number 2. So before performing Armstrong, let's say Fibonacci series sequence, we will first do B, that is generate prime numbers between 1 to n. Is this clear? Okay, fine. So now we will talk about prime number. So as I just explained, prime numbers are the numbers which are divisible by 1 and itself, right? So how we can say that number is completely divisible by 1 and itself? When we can say? When the remainder is 0. It means that the number is completely divisible. Okay. Now for example, 12 mod 2. How much is the remainder? 0. So what is meaning of remainder 0? What is meaning? This is mod operator. Mod operator gives remainder of the division. So what is meaning of 0? It means that 12 is completely divisible by 2. Now if I am doing 12 mod 5, what is the remainder? Remainder is 2. Remainder is 2. Now whether 12 is completely divisible by 5? No. Right? It is not completely divisible. So here what we have to say, what we have to find in this program, we have to find that our number is divisible by only 1 and that number itself. Only 1 and that number itself. In rest of the cases, it gives remainder which is not equal to 0. So if remainder is 0, it means it is completely divisible. So assuming that we are asking user to please enter a number. So user has given one number in n, and then what we are going to do, we are going to check whether that number is completely divisible by let's say 1, 2, 3, 4, 5 up to n. So we will check all the numbers in that range from 1 to n, and we will check how many numbers completely divide that n number, जो भी हमारा n input दिया है उसको. In that case, if the count is more than 2, in that case what we can say? The number is not prime. If count is only 2, that means 1. If that number is getting divisible by 1, it means what? Count will be 1. Now when that number is getting divisible by itself, then count value is going to become 2. 1 and 2. It means that it is divisible by only 2 numbers, 1 and itself. Right? So when the value of count is equal to 2, we will say that that particular number is prime number. And in case of else, that means if the value exceeds more than 2, it means what? The number is not prime number. It is also getting divisible by any other number other than 1 and itself. Right? So for that purpose, we are going to use for loop. So how is the for loop? So we need to understand its syntax. How is the syntax of for loop? So in for loop, we have for, then initialization of counter variable. That means how many times we want following statement to get executed. That is the counter variable, which is going to count the number of times we want to execute the following block of statement. Is this clear? That is called as initialization of the counter variable. Then we check the condition That means whether the value of that counter variable exceeds some specified count. It should not go beyond that. So we use here a terminating condition. Now, after that termination condition, we have to either increment or decrement the counter variable. So here increment or decrement the counter variable depending on whether we are going from lower limit to upper, then increment. If we are going from upper to lower, then decrement. Is this clear? Okay. Now here we use the block of for statement, and here we write statements or statement depending on our requirement. What we want to implement, based on that we may write multiple statement or we may write a single statement. Is this clear syntax? Okay. Now let me give you one simple example. So I write for, then I is equal to, let's say 1, then I is less than equal to 10, and then I plus plus. So what this for loop is, for this for loop the value of I, which is used as an initialization counter variable, goes from 1 to 10. So first what will happen here, in this case the value of counter variable will be initialized with 1, then it will execute, it will check the condition, and then it will go and execute these statements. Then when these statements are over, it will come back to the for loop and it will increase the value of that counter variable by 1, it will become 2. Then it will check whether 2 is less than equal to 10, condition is true. It will again enter in the for loop, it will execute the for loop, and then after completely executing of this block, it will go back to the for loop and it will increase the value of I by again 1. So it is going to become 3. 1 से start हुआ, then 2, then 3. Again it will check 3. So it will go up to 10 and then finally it will become 11. So whether 11 is less than or equal to 10? No. So condition is what? False. In that case the program will terminate. That is the way the for loop executes. Is this clear? Okay. Now I will show you the demonstration of simple for loop, how for loop executes. Fine. In file, create on new, as the name is not given, the name is no name.c. So I said F2 for saving the file. I go to the proper location, and in that I will give name to this file as for demo. So for demo.c. This is what I am going to create. Okay. So as per our practice, we will include header files first. I have already explained what is header file previously, so I'm not explaining for what I'm writing this. Let's write wide main. Now as I said, let's say we have one variable as n, counter variable I'm declaring as I, and then I'm going for my for loop. Before that CLR SCR is I'm putting here, and now I'm going for loop. For I is equal to 1, I initialize I with 1, then I is less than equal to 10 and I plus plus, and then I'm putting one statement inside the block of for loop, that is print. What I want to print the table of number 5. I want to print table of number 5. So I'm writing here backslash n, backslash n, then let me put here %d as a format specifier for integer, and comma, the value is coming from what? I into n. Now let me tell you why I have taken I into n. We know that how we have formed the table of any number. In that, for finding table of any number, what we do, for example, I have number 5. So what I do, 5 into 1, that is 5. Then what I do, 5 into 2, that is equal to 10, right? Okay. Then after that, 5 into 3, that is equal to 15, and so on. So that is the method of creating the table of any number. right? So here my 5 is stored in what? Variable n, right? So I have to multiply this n, I have to multiply this n with what? With what? 1 to 10. Are you getting this, everyone? So when I have to multiply n with 1 to 10, instead of writing that statement 10 times, I am using now for loop. So in for loop, what will happen? The value of I is going from 1 to 10. So that's why I have used here for multiplication I variable. So initially the value of I will be 1. Now 1 is less than 10, that condition will be checked, and then as it is true, this statement will be executed. So that means 1 into 5, that we will get as a output. Is this clear? Okay. So now after end, I've just put here get ch, and I will show you the execution of this program with window, that is output window, and with watch as. So in watch I have to add variable as n, then I have to add variable as I, and I have to add variable as I into n. Now what is this watch? Whatever variable we use, whatever changes happens to that variable during execution, that is what we can verify and watch in the watch window. So if any mistake in our logic, our output is not coming correct, then in that case we can go for this watch window. Okay. Now to check the output of this program, now I will do line by line compilation. What I will do? Line by line compilation. So my program is correct, no any error. So I said F7. Now my program started execution. See, now see everyone, variable declaration. So as soon as variable declaration goes, the values in watch window changes. Now what is value of n currently in watch? Minus 29222, because it is a garbage value. In C, whenever we declare any variable, the content of that variable or memory location is garbage. We have to assign some value to that variable. So now when that statement will get executed, the value of n will change to 5. Got changed, right? Now CLR SCR, when that statement will get executed, see the output window, this output window, the output window will get clear. See everyone, got clear? Now when that statement will start execution for loop, it will first initialize the value of I to 1. Now current value of I is 842. Now it is going to change to 1. See everyone, got changed? Now the value of I we have 1, the value of n we have 5. So what will be the value of I into n? 5, right? And that is what we are printing by using print statement. Everyone observe the output screen. The value of that I into n will be printed on the output screen, that is 5. Now the value of I is incremented to 2. See the watch window. So 2 into 5 will become 10, and that is what we are going to get as output. We got output as 10. Okay. Now 15, 20, 25, 30, 35, 40, 45, 50. Now what is the current value of I? 11, right? So condition is false. So as soon as condition become false, see here the flow of execution jump to get ch statement. So it has jumped to get ch. Yes, that means now the output screen will come in front of us, and now the program got executed or terminated successfully. Is this clear how for loop executes? Right everyone? Okay. Now we are going to use this for loop for finding whether a given number is prime or not, right? So how we will find this number prime or not? See here, we will take one more variable as count variable, and we will declare its value as 0. And now we will check. What we will check? Now let me remove this, not required now. So now we will check. What we will check? We will check whether that number is divisible by 1 and that number itself. So we will do if what? If that number, that means n, mod I is equal to what? 0. If it is divisible by that number, that means what? Mod will be 0, right? So if it is completely divisible, then in that case increase the value of count by 1. I hope everybody knows the meaning of count plus plus. It is count is equal to count plus 1. Count equal to count plus 1. Now, if it is not, then the value of counter will not be executed. Right, everyone? Fine. So now see, we will begin with what? For I, and I is going to divide our n. So we will get 0. So count value will be 1. And if my number is, for example, 5, so it will not get divided by 2, 3, 4. It will again now going to be divided by 5. So value of count will be 2. Right? Now for 4, we'll get divided by 1, then 2, and then 4. So count value will be 3. Right? Are you getting this? So when my value of count is 2, what it means? If count equal to 2, what it means? Tell me. It means that my number is prime. It means that my number is prime, and number is coming from variable n. Else if it is not 2, then in that case tell me my number is not prime. So %d is not prime. Okay, so let's compile our program. Everything is okay. Let's run it now. Okay, so what answer we got? Control F9. 5 is prime. Yes, we know 5 is prime. Okay, now I'm giving input as, let's say, 6. So whether 6 is prime? Yes or no? So 6 is not prime. Is this clear to everyone? Okay.